All right, thanks for watching and welcome to the third round of Extreme Algebra. Today we'll be talking a bit more about functions, about compositions, inverses, and a little bit about parabolas. So let's get ready for some functions. Okay, question 1. Given the graph of y equals x squared, how would you draw the graph of y equals x minus 4 squared minus 2? Now, because of this minus 4, you have to shift the graph to the right by 4 units. Now, I know this seems a bit paradoxical because minus 4 would mean shifted to the left, but think of it in terms of time. If you do time minus 4, it's kind of time is running out, and you're shifting the graph to the future a little bit. So the graph of x minus 4 squared would kind of look like that. So here, if you want, the vertex would be at 4. And if you do minus 2, it just means you shift the graph down by 2 units. Okay. So really the answer here is this parabola with vertex 4 comma minus 2. And that's what your answer is. Okay. So that is y equals x minus 4 squared minus 2. So again, you shift it right and then you shift it down. All right, next question, very similar in nature. Question 2. Suppose I give you the graph of absolute value of x. How would you draw the graph of absolute value of x plus 4 minus 2? Now, because we have plus 4, it's as if I've given you more time. So you're actually shifting this to the left by 4 units. Shifting it to the left by 4 units to get absolute value of x plus 4. Okay. So in particular, this 0 here, so the 0 of this function becomes minus 4. And then to this graph, you just shift it down by 2 units, just as before. By 2 units, and then in the end you still get this V shape, but shift it to the left and shift it down. So again here you shift it to the left because of this plus 4, and you shift it down because of this minus 2. And kind of, if this is like the vertex of the absolute value, the new vertex is minus 4 comma minus 2. Okay. Good. All right, next question. This time again similar. Suppose you have the graph of y equals square root of x. How would you draw the graph of y equals square root of x minus 3 minus 4? So again, here we have a minus 3, so we're running out of time, so you're shifting it to the right by 3 units. Okay. So the graph of square root of x minus 3 looks like that. And then here you have a minus 4, you shift it down by 4 units. And so what this becomes, it's somewhere here. So it starts at the point 3 comma minus 4, and then just looks like your usual square root. Again, minus 3 you shift it right, minus 4 you shift it down. All right, next question. Question 4, let's try to draw the graph of x squared plus 4x minus 1. Now, if you see those quadratic equation questions and they ask you to graph it, the best thing is just to complete the square. So here, let's see what we get. So we have y equals x squared plus 4x minus 1, but x squared plus 4x, that looks like the beginning of the expansion of x plus 2 squared. So let's just add and subtract 4 to this. So x squared plus 4x plus 4 minus 4, and to cancel this out, and then we have this minus 1. Okay. And the nice thing is, as I said, this looks like a perfect square, and in fact it is, because then we get y equals x plus 2 squared, okay. And then minus 4 minus 1, that's minus 5. So in other words, what does this look like? So just like the previous problems, you start with x squared. Okay. Again, with vertex 0, 0. And then, since you're adding 2, I'm giving you more time, so you shift it to the left by 2 units. Okay. Maybe look something like that. And then it's not quite drawn on scale, but then this thing, you shift it down by 5 units. So where did my red thing go? So in the end, you get something like that. So the parabola, so y equals x squared plus 4x minus 1. And in those questions, it's always good to give me the vertex. So here the vertex is at minus 2 because we shifted to the left, and minus 5 because we shifted down. And that's a nice thing. All those quadratic things, they're parabolas, but they usually look shifted or maybe dilated or something. All right, next question. Now, let's graph y equals 3x squared minus 6x minus 3. Again, it's a quadratic function, so you might guess correctly that the graph looks like some kind of a parabola. And for this, again, we would need to complete the square. But notice, first of all, there's something nice about this function, is that every term has a common factor of 3. So you can factor a 3 out of this. So y equals to 3 times x squared. 6 is 2 times 3, so this becomes minus 2x and then minus 1. Again, you can always check by expanding all the terms out, and you get this. And again, here, we want to complete the square. So notice, this looks like x squared minus 2x plus 1. So we start with this and try to clean this up. So this becomes 3 times x squared minus 2x plus 1. But to get rid of this plus 1, you have to subtract 1. And you still have this minus 1 here, so you keep it there. And so basically what you left is the following. 3 times. So this whole gibberish becomes x minus 1 squared. And you still have this minus 2. So we get this. So in the end, what we have is the following. So yeah, we get 3 times x minus 1 squared and then minus 6. All right, and the question is, what does this look like? So it's already good. It tells you that, well, it's a parabola, but we need to shift and dilate it a little bit. So So again, you need to do it step by step. It's very important. So let's start with the parabola y equals x squared. Now, you need to go like inside out, kind of like that movie. So if you see, you start with x minus 1 squared. So minus 1, time is running out, so you shift it to the right by 1 unit to get x minus 1 squared. Okay. Now the question is, what happens, what does this 3 do? It just dilates it, sort of shrinks it a little bit vertically. So the difference between x minus 1 squared and 3 times x minus 1 squared is that this one looks a little bit skinnier in some sense. So that is y equals 3 times x minus 1 squared. And last but not least, what about this minus 6? Well, it shifts it just down by 6 units. So kind of what this finally looks like is maybe like this picture here. So it's like a very skinny parabola that is shifted to the right by 1 unit and shifted down by 6 units. So the new vertex is, so again, 0 becomes 1, so 1 comma minus 6. Again, 1 because you shift it to the right, minus 6 because you shift it down. And that is your original function, 3x squared minus 6x minus 3. So in those questions, again, try to complete the square and do this like step by step. That's what I'm saying. So here, x minus 1, you shift it right. 3, you dilate it. And then minus 6, you shift it down. All right, next question. All right, next question. How would you graph y equals 4, absolute value of x plus 2 minus 5? So again, same thing as before. You just have to do it step by step and figure out what every transformation is. So you start with absolute value of x, so this V shape. And now focus first on x plus 2. Again, x plus 2, I'm giving you extra time, so you shift it to the left. It's kind of going to the past. So you shift it to the left by 2 units to get something like that. To get y equals absolute value of x plus 2. And again, in particular, the vertex 0 here becomes minus 2. And what does this 4 do? So let's focus on the second part now. Just for the parabola, for the 4, just makes it a bit skinnier. So dilates it upwards. So maybe this is what your new absolute value looks like. So this is 4 times absolute value of x plus 2. And last but not least, this minus 5 just shifts it downwards by 5 units. So maybe in the end what you get is this really skinny absolute value. So y equals 4 times absolute value of x plus 2 minus 5. So again, just to recap, the x plus 2 shifts it to the left. All right, next question about piecewise defined functions. So let's graph the function f of x, which is minus 1 if x is negative, 2 if x is 0, and 3 if x is positive. So those kind of functions, they're defined by cases. And the best thing is just to read line by line. So what this is saying is, if x is negative, so in this region, the function is minus 1. So it's minus 1, minus 1, minus 1, minus 1. Except at 0 here, we don't really know what it is. It might be minus 1, it might not be. So you just put this little bubble, okay, that's not filled in. Okay, just to emphasize that the value here might not be minus 1. Now, furthermore, if x equals 0, we know that the value is 2. So f of 0 is 2. So therefore, to emphasize that f is defined at 0 and its value is 2, you put this filled in bubble. So this just means f of 0 is 2. And then if x is positive, we know that f is 3. So at 0, it might not be 3, because 0 is not positive. That's why you put this bubble that's not filled in. But then if x is positive, we know that f is 3 everywhere. So this function looks like a staircase or like a switch. You go from -1 to 2 to 3. All right, since this was so much fun, let's do another example of this. All right, another interesting kind of function. So f of x, it's -3/4 x minus 1, except at Another interesting kind of function, here f of x, it's -3/4 x minus 1, except at -2, where we force it to be 2. So the way this function looks like, again, the graph is completely optional, is that everywhere it's a line, so -3/4 x minus 1, kind of like this, except at -2, maybe here, we define it to be 2. So it's kind of the line, then it jumps to 2, and then becomes a line again. Okay? And so, if we want to calculate values of f, we just need to make sure, is the input -2 or not? Let's say, for instance, f of -4. The input here is not -2. So we have to use the first definition. So -3/4 times -4 minus 1. Okay. And while here there's a nice simplification, this 4 cancels out, this minus cancels out, and you get 3 minus 1, which is 2. How about now f of -2? Well, notice -2 is x equals -2. So you have to use this definition. Do not use this definition, which is only valid for x not equal to -2. So here definitely f of -2 is 2. And lastly, f of 1. Well, 1 is not -2, so you have to use this definition. So -3/4 times 1 minus 1, which you can simplify. So -3/4, 1 is 4/4, and you end up with -7/4. Okay? So those are the answers. It is 2, 2, and -7/4. So again, for those piecewise defined functions, just read exactly what the definition says here. So here it says, other than the illegal value of -2, use this line definition. All right, next question. All right, next question, talk inverse to me. So suppose f of x is 1 over 3x and g of x is 1 over 3x. The first question is, calculate f of g of x. And what this means is, just use the definition of f of x, but instead of x, write g of x. So since f of x is 1 over 3x, f of g of x is 1 over 3g of x. But remember that g of x is 1 over 3x. So it becomes 1 over 3 times 1 over 3x, which is just 3x, because you flip it, over 3, and that's x. Similarly, g of f of x, what this means is you take the definition of g, but replace x by f of x. So it's 1 over 3 f of x. Well, I'd like to remind you, f of x is 1 over 3x. And so again, by the same formula, this becomes 3x over 3, which is x. Now, very important, because you found f of g of x equals x and g of f of x equals x, you can conclude that f and g are inverses of each other. inverse literally means f of g of x equals x and g of f of x equals x. So kind of f and g, they undo each other. All right, let's do a similar exercise. So second part of the problem. Okay, now if f of x is x plus 2 and g of x is x plus 2, let's calculate f of g of x, which just means use the definition of f, but replace x with g of x. So since f is just adding 2 to the input, f of g of x is just g of x plus 2, and that becomes x plus 2, which is x plus 4. And by the way, already we can conclude that f and g are not inverses of each other. Because inverses would mean f of g of x is x and g of f of x equals x. So since we already found that f of g of x is already not x, we can already say that they're not inverses. But for sake of completeness, let's calculate g of f of x. So it just means use the definition of g, but replace x with f of x. So this becomes f of x plus 2, which is x plus 2 plus 2, and that's x plus 4. They're not inverses. All right, next question. So suppose you're given a function with the following values, and the way you have to read this is as follows. So what we're saying here is that g of minus 5 equals 7. Or g of minus 2 equals 0, g of minus 1 equals 6, and g of 7 equals 5. And the first question is, find g inverse of 7. So what this means is as follows. If g inverse of 7 equals x, what this means is that g of x equals 7. So g inverse 7 just means which input gives you output 7. And here you just have to look at all the values. So among all the outputs, which input gives you 7? Well, notice there's just one value whose output is 7, which is minus 5. So because g of minus 5 equals 7, g inverse of 7 is minus 5. So again, g of minus 5 equals 7. So g inverse of 7 is minus 5. So again, just to repeat, g inverse 7 is the input whose output is 7. So it always answers the question, g of what equals 7? And here, g of minus 5 equals 7. Now, of course, this is a multi-part problem, so let's do the next part. Now suppose we give you h of x is 3x minus 10. Now the question is, what is h inverse of x? So you kind of have to ask yourself is, given an output y, which input x gives you 3x minus 10? And so to do this, all we need to do, set y equals 3x minus 10. And all you need to do is you have to solve for x. Okay, it gives you the input whose output is y, and so we get 3x minus 10 equals y, 3x equals y plus 10, and then x equals this over 3, so y plus 10 over 3, so that's y over 3 plus 10 thirds. So that gives you h inverse of y, but since we want everything in terms of x, we just have to replace y with x, and we get h inverse of x is x over 3 plus 10/3. And that's the answer. So again, to solve for inverse functions, just set y equals to your function and solve for x. This gives you a formula with y, but then just replace y with x. And last but not least, there was this really small question: what is h of h inverse of 5? So h composed with h inverse. So it just means h of h inverse of 5. So you have to understand h of h inverse is just itself. So in particular, h of h inverse of x equals x. Again, jh inverse undoes h. So in particular, h of h inverse of 5 is just 5. So that's it. That's a nice thing about inverse functions. All right, next question. Next question. So suppose h of x is 3x over 8x minus 9, and the goal is to find h inverse of x. The strategy is exactly the same as the previous problem. So let y be 3x over 8x minus 9. And what you want to do, you want to solve for x, which I agree here it's a little bit trickier, but still doable. So if you want, you can just cross multiply. And you get y times 8x minus 9 equals 3x. And then expand this out, so you get 8xy minus 9y equals 3x. And remember, your goal is to solve for x in terms of y. So put all the x's on the left-hand side. So we get 8xy minus 3x. So you put this here, and the y on the right-hand side equals 9y. And the nice thing is, x factors out. So x times 8y minus 3 equals 9y. And that tells you that x is 9y over 8y minus 3. But since you want h inverse of x, you just replace y with x, and you get, I believe, 9x over 8x minus 3. Okay. So again, very standard. So you said y equals to your function, and you solve for x. And then there's just a couple other things. So I believe they say find the domain and range of h inverse. So, in fact, I want to show you this is much easier than you think. How do you find the domain of h inverse? Well, here you have a formula, and remember, you just want to make sure that the denominator is non-zero. So for the domain, we need 8x minus 3 to be non-zero, and so 8x is not 3. So x is not 3/8. Okay. And so what is the domain? All the numbers except for 3/8. Kind of like this. So in other words, it's just the interval minus infinity up to 3/8 and 3/8 up to infinity. So the way you write this is minus infinity. Again, parentheses because you excluded, and then 3/8. Again, and since you want to say both pieces, you write or this u, and then 3/8 comma infinity. So that's the domain of h inverse. And the question is, what is the range? Now, in general, it's very hard to find the range of functions. But here there's a really neat fact. Namely, the range of H inverse is just the domain of H. And similarly, the range of H is the domain of H inverse. So all you need to do is find me the domain of H. And here what you want 8x minus 9 to be non-zero. And in an exactly identical fashion, you find x is not 9/8. Exactly the same, and in particular for the range, you just do the same thing, but you replace 3/8 by 9/8. So the answer is minus infinity 9/8 union 9/8 comma infinity. Again, you just literally repeat this, but we replace 3 by 9, I believe. So again, that's why inverses are nice. They allow us to find domains and ranges very easily. All right, next question. Here are some 6 beautiful graphs. The question is, for each graph, is the function 1-to-1? And for this, the best thing to use is what's called the horizontal line test, which is like the vertical line test, but horizontally. More precisely, if for every horizontal line, it goes to the graph of the function at most once, so either 0 times or 1 time, then it's 1-to-1. So you see here, for the first function, no matter which horizontal line you draw, it goes to the function exactly once, actually. So this one is 1-to-1. So this is yes. How about this one? Well, look, this horizontal line goes through once, this one as well. This goes through it 0 times, which is okay. Also 0 times, once, once, once. So in fact, also here, it's 1-to-1. What about here? Notice this horizontal line goes through the function twice. So it's not 1-to-1. So if you find one line that crosses it twice, it's not 1-to-1. What about this one? Well, this one goes through it once, 0 times once. But notice here, it goes through that function twice. So here it's not 1-to-1. What about here? Well, once, 0 times, once, once, 0, 1, 0, 1. 0, so I drew it badly, but it should be here. So this one, it turns out, is also 1-to-1. So yes. And how about here? Well, again, it goes through every horizontal line once, so it is also 1-to-1. So it turns out everything is 1-to-1 except this picture, the triangle, and this picture with the dots of the same height. Everything else is 1-to-1. Okay. So again, horizontal line test, pretty cool. Highly recommend. All right, next question. All right, what time is it? It's quadratic formula time. So let's solve for W in the following equation. 4W squared equals minus 9W minus 2. So the way you do this, you put all the W's on the left-hand side. So 4W squared plus 9W plus 2 equals 0, which is of the form AW squared plus BW plus C equals 0, where again A is 4, B is 9, and C is 2. And then you just use the quadratic formula, which says that W, it's minus B plus or minus square root of B squared minus 4AC over 2A. And that gives you, so minus 9 plus or minus square root of 9 squared minus 4 times A, which is 4 times 2, over 2A, so 2 times 4. And that gives you a minus 9 plus or minus square root of, so 9 squared is 81, 4 times 4, that's 16, times 2, that's 32. and then over 8. And that gives you minus 9 plus or minus square root of, so 81 minus 32, that's 49 over 8. And the nice thing is square root of 49 is just 7. So in the end you have W, it's either, it's minus 9 plus or minus 7 over 8. And that becomes either minus 9 minus 7 over 8 or minus 9 plus 7 over 8. And that simplifies quite nicely. So it is minus 16/8 or minus 2/8. So that's minus 2 or minus 1/4. So those are the solutions to this equation. All right, here's another fun quadratic equation. So solve for n in the equation n plus 4 squared equals 2n squared plus 14n plus 24. So do not take square roots here. That would just make it horribly complicated. My recommendation is expand out this squared. So this is of the form a plus b squared. So this is a squared plus 2ab, so 2 times n times 4, plus 4 squared, and that's 2n squared plus 14n plus 24. And this just simplifies to n squared plus 8n plus 16 equals 2n squared plus 14n plus 24. And my recommendation is put everything on the left-hand side, move it to the right-hand side. So 0 equals 2n squared plus 14n plus 24 minus n squared minus 8n minus 16. And that simplifies quite nicely. So 2n squared minus n squared, that's just n squared. 14n minus 8n, that's 6n. Okay. And then 24 minus 16, that's 8. So you're left with n squared plus 6n plus 8 equals 0. And we can now solve this using the quadratic formula. So let's see what we get. So n, again, this is of the form an squared plus bn plus c, where a is 1, b is 6, and c is 8. And that tells you n equals minus b, so minus 6, plus or minus square root of b squared, so 6 squared, minus 4ac, so 4 times 1 times 8, okay, over 2 times a, so 2 times 1. Okay. And let's see, okay, I got scared for a second, but that becomes minus 6 plus or minus square root of 36 minus 32 divided by 2. And that is minus 6 plus or minus square root of 4 over 2. But the nice thing is square root of 4, that's just 2. We're super nice today. We don't give you square roots. So in the end, what we end up with is either n is minus 6 minus 2 over 2, or minus 6 plus 2 over 2, and that becomes minus 8 over 2, or minus 4 over 2, and that's minus 4 or minus 2. And I believe those are the solutions to your equation. All right, a little physics problem. I know there were lots of words in the problem, but basically what it's saying is, suppose you're throwing a ball down and the height of the ball is 4 plus 37t minus 16t squared. The question is, when is the height 24 feet? So all you need to find out is, when is this equal to 24? So all we need to solve is 4 plus 37t minus 16t squared equals 24. And so if you want, how about we put, again, everything on the right-hand side, just to make the t squared be positive. Then what you get is 24, and then minus 4 minus 37t plus 16t squared equals 0. And you can simplify this a little bit, so you get 16t squared minus 37t plus 20 equals 0, which is another quadratic formula. So again, this is at squared plus bt plus c equals 0. And then you can just solve for t as follows. T equals, again, minus b plus or minus square root of b squared minus 4ac over 2a. And so, remember, b is minus 37. So minus b is minus 37. So just be careful. Okay. Plus or minus square root of minus 37 squared. And then minus 4 here, a, which is 16, and then c, which is 20, okay, over 2a, so over 2 times 16. Okay. And that does give us a little nightmare, but let's see, that becomes 37 plus or minus square root of, and again, let me calculate that. So minus 37 squared minus 37 squared, that becomes 1369. So careful, don't put minus here. It's not the same as minus 1369, so that's a big mistake people do. And then 4 times 16 times 20, so minus 1280. And then divided by 2 times 16, which is 32, again, my age, and that becomes 37 plus or minus square root of, so 1369 minus 1280 becomes square root of 89 over 32. Okay. And so in particular, we have two choices. We have t equals 37 minus square root of 89 over 32, or 37 plus square root of 89 over 2, and then, not over 2, over 32. And we can solve this. So the first one gives you roughly 0.86. Again, the units here, I think, are seconds. So either 0.86 seconds or 1.45 seconds. And I think that's it. So again, enough physics for today. All right, next question. Suppose you have this beautiful parabola that I drew here. Again, maybe not up to scale. And just some basic questions about the shape. Does it curve upwards or downwards? So remember this mnemonic, up like a cup, down like a frown. So this looks, it's going upwards. So it is going upwards. And then the question is, what are the x-intercepts? X-intercepts just means wherever it crosses the x-axis. So here I believe at -4 and 2. What about the y-intercept? Where does it cross the y-axis? Here at -8. And then let's first do the vertex, because it gives us the axis of symmetry. So the vertex, again, where this lowest point is, it looks like it's at -1, comma, -9. Kind of halfway between -8 and -10. And in fact, the nice thing is, what is the axis of symmetry? It's just kind of the x-coordinate of the vertex. So wherever the vertex is, so because the vertex is at -1, comma, -9, the axis of symmetry is at x equals -1. Again, x equals something because we have a vertical line. So it's an interesting problem. It took forever to set up, but actually to answer it is not that bad. All right, next question. All right, the next question is, so suppose again you have this parabola, x squared minus 4x minus 12, and the first question is find the x-intercepts, and also the next question is find the coordinates of the vertex. So you could do it all at once, but let's treat them as separate questions. So x-intercepts just means set that equal to 0. So what we want is x squared minus 4x minus 12 equals 0. And for this, we have to use the quadratic formula. So again, this is of the form ax squared plus bx plus c equals 0, where a is 1, b is minus 4, and c is minus 12. So what we get now is x equals minus b, so minus minus 4, plus or minus square root of b squared, so minus 4 squared, minus 4ac, so 4 times 1 times minus 12, over 2a, so over 2 times 1. And you can simplify this. Then this becomes minus minus 4, which is 4, plus or minus, again, square root of minus 4 squared, be careful, that is 16, not minus 16, and then 4 minus 4 times minus 12, it's plus 48, okay, over 2. And I believe this becomes 4 plus or minus Nintendo 64 over 2. And square root of 64, that is 8. So it's either 4 plus 8 over 2 or 4 minus 8 over 2. Okay. And that becomes 12 over 2 or minus 4 over 2, and that gives you either 6 or minus 2. So here the x-intercepts are minus 2 or 6. Okay, so those are the x-intercepts, and then the question is, how do you find a vertex? In my opinion, just do it again. So this time what you would like to do, just complete the square in this. So if you have y equals x squared minus 4x minus 12, try to complete the square. So that kind of looks like x squared minus 4x plus 4. Except to get rid of this plus 4, you subtract 4 and minus 12. And that gives you, so this is x minus 2 squared minus 16. And what's nice about this, it actually gives you the coordinates of the vertex. And let's think about how it does it. So if you start with x squared, what this is telling you is shift it to the right by 2 units and down by 16 units. So the graph looks something like that. And in particular, the vertex 0, 0 becomes a vertex 2, comma, minus 16. And that is the answer. So the answer is 2, comma, minus 16. Because you shift it to the right and you shift it down. That's how it goes. All right. Okay, so the next question is a little bit of a word problem, but suppose you're a car manufacturer, and given the number X of cars, the unit cost of making cars is C of X, which is 0.4x squared minus 192x plus 33,821. So I believe the cost of making each car. And the question is, what is the smallest possible unit cost? And for this, we would need to use a formula for the minimum, which will be proven in calculus if you're interested. But if the cost is ax squared plus bx plus c, then the minimum cost is, I guess, not the minimum cost, it's kind of the smallest x is, or the smallest input, simply given by minus b over 2a, which in this case is minus 192 over 2 times 0.4, and that is 192 over 0.8, and let's calculate that. 192 over 0.8, and that's 240. But careful, this is not the answer. The optimal number of cars, or the best x, is 240, but that's not the smallest cost. The smallest cost is C of 240. So the answer is C of 240, which is 0.4 times 240 squared minus 192 times 240 plus 33,821. And now let's calculate that. So 0.4 times 240 squared. Gotta get used to that. Okay, minus 192 times 240, and then plus 33,821, which gives me 10,781, which is definitely way less, and again, dollars, definitely way less than what I paid for my car, with my Peyam track. But let me just check. Yes, it's correct. Okay, I wasn't sure of myself, but all right, enough word problems. Next question. All right, so let's continue with a very fun problem. Let's find all the zeros of g of x, which is 5x times x minus 16 squared times x minus 3 squared. And for this, it's very easy because you can literally read off the zeros. So basically, such kind of polynomial is 0 if and only if one of these factors is 0. So essentially what we get, it's either 5x equals 0, which gives you x equals 0, or x minus 16 equals 0, which gives you x equals 16, or x minus 3 is 0, which gives you x equals 3. So in this case, there are 3 zeros. It's either 0, 3, or 16. Okay. And since this was so much fun, let's do another problem of this type. So now let's try to find the zeros of 5x squared times x minus 8 squared times x plus 6 cubed, but this time with multiplicities. Just saying how often are they repeated. And again, same spiel as before, such kind of polynomial, it's 0 if and only if each of its factors is 0. So what you get is, first of all, 5x squared equals 0, but this just means x equals 0. But with what multiplicity? Very easy. The multiplicity is just the exponent. So here, x0 is with multiplicity 2. And then let's do the same thing. So x minus 8 equals 0. That means x equals 8 with multiplicity 2. And lastly, maybe the trickiest one, x plus 6 equals 0, but this gives you x equals minus 6. And this time with multiplicity 3. Okay. All right, very nice. And since this was so much fun, one more problem of this type. Next question, maybe the easiest question of today. Let's find a quadratic function h with zeros 5 and 7. Well, all you need to do is find h of x be x minus 5 times x minus 7. So x minus the first 0 times x minus the first 0. And that's it. You can, I wonder if they ask you to expand it out, but you could FOIL it out to get x squared minus 7x minus 5x plus 35, and that would give you x squared minus 12x plus 35. That would work, or any number you can also put here. That's fine. All right, next question. All right, next question. So you have this parabola with vertex 4 comma minus 2, and all we need to do is to find the domain and the range. Domain, super easy. For quadratic functions, they're defined everywhere. So there's no illegal value here where it's not defined. So the domain is just minus infinity comma infinity. What's slightly trickier is what is the range? In other words, what are all the possible values of this function? Well, notice there are no values of this function above minus 2. So anything above minus 2 is not attained, but anything below minus 2, it's attained. So let's say you want minus 3, there's certainly, in fact, here 2 values where the function is minus 3. Now the question is minus 2 in the range? Absolutely, because minus 2 is attained at 4, because this is on the graph. So in fact, what we want to say is the range is all the numbers smaller than minus 2, and you can write this as minus infinity comma minus 2. So anything going from minus infinity all the way to minus 2, and you put this square thing, square bracket, to say that you include minus 2. All right, next question. All right, next question. Let's find the range of this function. J of x is minus 3x squared minus 18x minus 28. And for this question, it's best to complete the square, because remember in the previous question with the graph, it was easy to do because we had the graph. So now let's try to do this. So first of all, because of this minus 3, let's factor out minus 3. So minus 3 times x squared, I believe, plus 6x. And then this is kind of ugly. In fact, let's leave it like that. You'll see why. So minus 28. And now, well, this looks like the beginning of a love story. It looks like the beginning of a perfect square, which is, I believe, x squared plus 6x plus 9. So we get minus 3 times x squared plus 6x plus 9, and then minus 9, and then minus 28. And that's the same thing as minus 3 times x plus 3 squared, and then minus 9, and then minus 28. And now the nice thing is you can expand this out. So you get minus 3 x plus 3 squared, and then plus 27, and then minus 28, which tells you in the end our function is as follows. J of x, it's minus 3 times x plus 3 squared minus 1. Okay, and now let's see how to draw this. So it's slightly trickier, but let's start with x squared. So this is x squared. And then the first thing is to do this plus 3. And remember, plus 3 means you shift it to the left by 3 units. So this 0 becomes minus 3. So that's what that looks like. But then, what does that mean? This 3 here means it gets a little bit skinnier, but because of this minus 3, you have to flip it. Okay? So this is kind of your minus 3x plus 3 squared. And lastly, you shift it down by minus 1. So this is what your end parabola looks like. So this is your minus 3x plus 3 squared. Minus 1. And now let's just look at what where the vertex is. So you shifted it by 3 here, you flipped it, doesn't matter, and then you shifted it down by 1, and therefore the new vertex is minus 3 comma minus 1. Why is this useful? It's because now we can find a range. Notice, again, the y-coordinate is minus 1. Anything less than minus 1 is attained. Okay? And anything bigger than minus 1 is not in the range. So what this tells us is the range is all the numbers less than or equal to minus 1. Or in other words, the range is minus infinity comma minus 1. All right, next question. Quite a lot of fun. So suppose you have this parabola with vertex 3, 3, and that goes through 5, 11. The question is, what is the equation of this parabola? Now, because we know the vertex is minus 3, 3, we already know that the equation is of the form y equals a times x minus 3 squared plus 3. Because again, this gives us the x-coordinate of the vertex, and this gives us the y-coordinate of the vertex. So all we need to figure out is a, and for this we just need to use the fact that it goes through 5, 11. So if x is 5, y is 11, so that tells you 11 equals a times 5 minus 3 squared plus 3. And that gives us an equation for a, because 11 is a times 2 squared plus 3. And so we get, I believe, 4a plus 3 equals 11. And then 4a is 11 minus 3. And that's, I believe, is 8. So a is 8 over 4. Which is 2, which tells us in the end what is the equation of this parabola. Y is 2 times x minus 3 squared plus 3. How cool is that? All right, another fun algebra question. So suppose g of x is x squared plus 9 and h of x is 2 over 9x. What happens if you do g of x and h of x? So g composed with g of x, that's just g of x. And all this means is, in the formula for g, replace x by g of x. So what does g do? It squares it and adds 9. So this just becomes g of x squared plus 9. But remember, g of x, that's just x squared plus 9 squared plus 9, and they said simplify, which I assume here means expand out the square. So this becomes x squared squared, so x to the 4th, plus 2 times x squared times 9, plus 9 squared, which is 81, plus 9, and then you're left with x to the 4th plus 18 x squared, and 81 plus 9 is 90. So that's the first thing, g of x, and then h of x is similar. And by the way, this is like putting in answer twice in your calculator. That's kind of a composition. So h composed with h of x, that is h of x. And all you need to do, you need to take the definition of h and replace x by h of x. So this becomes 2 over 9, not x, but 2 over 9 h of x, which becomes 2 over 9 times 2 over 9x. And again, you can flip it, so that becomes 2 over 9 times 9x over 2. This cancels out, and you get x. So if you do h twice, you get x. All right. Another question. So suppose f is x plus 2 over x minus 1, and g is 2x minus 3. Let's first find f of g of x. So it's f of g of x. And again, all that this means is take the definition of f and replace x by g of x. So this becomes g of x plus 2 over g of x minus 1. But g of x, that's 2x plus 3. So 2x plus 3 plus 2 over 2x plus 3 minus 1. And that becomes 2x plus 5 over 2x plus 2. Okay. Now, the next question was also, what is the domain of this? Usually you have to watch out when g is defined, but here g is defined everywhere. So here g is defined on R, which means that you just need to look at the domain of the resulting thing. And for this, all we want the denominator to be non-zero. So 2x plus 2 non-zero, so 2x not equal to minus 2, so x not equal to minus 1. Which means the domain is all the numbers other than minus 1, which you can write as minus infinity comma minus 1 union minus 1 comma infinity. All right, very good. Okay, again, super quick question. It looks very long, but it's very quick. So suppose the area as a function of radius is pi r squared, and the radius as a function of time is 14/3 t. What is the area as a function of time? And all they wanted you to do is to a of m of t, which is, again, pi, not r squared, but pi m of t squared. And that's pi 14/3 t squared. And they say don't simplify, so just leave it as that. Again, the area as a function of radius is pi r squared. The radius as a function of time is 14/3 t. So the area function of time is just a composition. All right, next question. Next question has to do with local maxima and minima. So the first question is, for this function, find all the local maxima of this function. So local maxima. Okay, so maximum or maxima. And that just means the highest points or the highest altitudes of this function. So here, let's see. Well, notice there are two peaks. Okay? And the peaks, the values of the peaks are precisely 3 and 4. So the local maxima are 3 and 4. Okay? There's also a minimum, but we don't have to worry about this. And the next question is, at which point are they attained? And all they ask you to do, for every point that you found, what is the corresponding x value? So for 3, notice it's attained at minus 3. And for 4, it's attained at 2. So the answer is for 3, it's attained at minus 3. And for 4, it's attained at 2. So it's very important to understand. Maximums and minimums, they talk about the y values. At which point they're attained, or all the values at which we have a local maximum and minimum, that's for the x values. All right, next question. All right, so luckily the next couple of questions are pretty quick. So suppose the graph of your function is this, and the question is, what is the absolute max and the absolute min? Well, let me again double check. Yeah, so in other words, what is the biggest value of the function and what is the smallest value of a function? If you think of this as a mountain, notice here the biggest peak is at 3. So the absolute max is at 3. What about here? So here you have some value and then you go up, down, up. And this just means it goes down to minus infinity. And because minus infinity is not a number, we simply say here that the absolute minimum does not exist. There is no smallest value of this function. Now, how about here? What is the absolute max and absolute min? Okay. Well, let's see what happens here. So you have here some value. You go up, but careful, this cannot be the maximum because it's not attained. So there needs to be one value that attains the maximum. So already we can scratch this. And then it goes down to minus 4, which is the smallest value. And then it goes up to this value, which is attained. So the absolute maximum here is 3. So again, the smallest peak of the function is minus 4. The biggest peak is 3. All right, and let's move on. Actually, the next double questions if you want. All right, now moving on to question 30. So suppose the graph of a function is given by this. So it's a function that starts here, goes up, down, and up. And the first question is f of 3 negative? And for this, you just have to read the function. So f of 3, well, it's definitely positive. It's not negative. So the answer here is no. And then the next question is, when is f positive? Well, look, here f goes from negative to 0, and then it's positive, 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 0, negative, 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 and then positive again, up to 2. And just a little technicality, which points do we include, which ones do we exclude? At minus 4, f is 0, which is not positive. So you exclude minus 4. All right, minus 2, f is 0. So you exclude this. So already we can say it's the interval minus 4, comma minus 2. And we put parentheses to exclude those points. Now, again, negative, 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 negative. At 1, it's 0. So we exclude this. So we want to say union 1, comma. Okay. Again, include, include, include. What about 2? Well, notice at 2, f is still positive. So here we actually include it. So you want to say 1, comma 2 inclusive. And that's why you put the square brackets. So just to recap, we put minus 4, comma minus 2, because we're excluding minus 4 and we're excluding 2. Or 1, comma 2, we're excluding 1 because f is 0 here, but we're including 2 because f is positive there. And lastly, maybe the easiest question, when is f 0? You just need to look at where f crosses the x-axis. Well, it's 0 at minus 4, at minus 3, and at 1. So the answer is simply minus 4, minus 2, and 1. And that's it. All right, moving on. All right, question 31. Now look at this beautiful function called a hyperbola, and we want to answer a couple of questions about this function. So first of all, what is the x-intercept? X-intercept means where does this graph cross the x-axis? And notice it crosses it precisely at minus 1. So the x-intercept is minus 1. What about the y-intercept? That's when the graph crosses the y-axis. So it's minus 2. And then two new features, vertical asymptotes and horizontal asymptotes. A vertical asymptote is a vertical line where the function blows up around that line. So where the function goes to infinity or minus infinity or both. Notice what's happening here. The function is blowing up near minus 2. So we would like to say the vertical asymptote is the vertical line that goes through minus 2. And that equation, it's simply x equals minus 2. Because notice here, the x value on this line is always constant and equal to minus 2. Now, what is the horizontal asymptote? It's some horizontal line that this function approaches at plus infinity or at minus infinity. And in particular, notice, if x goes to plus infinity, this graph seems to get closer and closer to this horizontal line. So already we can say this horizontal line is a horizontal asymptote. What's the equation? Well, here the y value is always minus 4, so the equation y equals minus 4. What about at minus infinity? Turns out this graph approaches the same line. Complete coincidence, so in the end, there's just one horizontal asymptote. Now, what's the domain of this function? Notice it's defined everywhere except for minus 2, because it blows up at minus 2. So we would like to say the domain is all the values except for minus 2. And remember, the way you write this is minus infinity comma minus 2 or minus 2 comma infinity. Now, what about the range? Well, notice this function attains all the values except for minus 4. It never actually reaches minus 4. It gets closer and closer to this, but never reaches it. So, in other words, the range is all the values except for minus 4, which you can write as minus infinity comma minus 4 union minus 4 comma infinity. Perfect. And that's pretty much all the info we have about this graph. All right, next question, almost done. All right, next question is, suppose you have this formula f of x equals minus 7 over minus 3x minus 9. The question is, what are the vertical asymptotes and the horizontal asymptotes for this function? Now, for the horizontal asymptote, all you need to plug in is x equals to plus infinity and minus infinity. So for the horizontal asymptote, again, it's not quite rigorous. You'll see the rigorous way of doing it in calculus. But if you plug in x equals infinity, you get minus 7 over minus 3 times infinity minus 9. But minus 3 times infinity, it's a very big and negative number. So in other words, it's minus infinity. And then, well, if you subtract minus 9 from minus infinity, it's still minus infinity. And then, minus 7 over minus infinity, that's 7 over infinity. And if you divide 7 by a gajillion, you get a very small number. So in fact, 0. So in particular, this tells you that if x gets very large, this function approaches 0. Okay. So in particular, a horizontal asymptote would be y equals 0. What about at negative infinity? You also need to check that. Well, it is similar though. So if you plug in x equals negative infinity, that becomes negative 7 over minus 3 times minus infinity minus 9, and that's minus 7 over, so 3 times infinity is infinity, minus 9, and it's minus 7 over infinity, and that still becomes 0. because it's like -7 over a billion or something. So even here we can say that y equals 0 is a horizontal asymptote as well. All right. If you found a different number, let's say 0 and 1, it would mean there are two different horizontal asymptotes. Now, what about vertical asymptotes? It basically means that there's a vertical line where the function blows up. Here, basically, you just need to look at the domain because everything is simplified. So for the vertical asymptote, and again, in calculus, you learn something different. So for the vertical asymptote, look at the domain. So we need -3x minus 9 to be non-zero. So -3x not equal to 9. So x is not equal to -3. So basically what this is telling you, and again, this only works as it's a rational function that's simplified. This tells you that near x equals -3, the function blows up. The function. So it kind of looks like this near -3. And in particular, what this is telling you is at my x equals -3, there is a vertical asymptote. So, just to summarize what we found, so we found a bunch of things. We found a horizontal asymptote at y equals 0, and we found a vertical asymptote at x equals -3, and then basically they ask you to graph this. So here's the horizontal line, y equals 0, and here's a vertical line, x equals -3. And if you're curious, again, completely optional at what the graph looks like, it should probably look like something like that, maybe. Either this or the opposite. You see, so it approaches y equals 0, okay, as x goes to infinity and as x goes to -infinity, and it kind of blows up at x equals -3. All right, last question of the day. Okay, now the last question is graph all the horizontal asymptotes and vertical asymptotes of this function. So again, for horizontal asymptotes, you just need to look at what happens as x goes to infinity and x goes to -infinity. Now here's the thing, and again, you will make this very rigorous in calculus. If x gets very large, essentially those factors are negligible. Because what is -4 compared to infinity squared? It's way, way smaller. So essentially at x equals -infinity, this function is close to -2x squared over x squared. So f of x is kind of roughly equal to -2x squared over x squared. And this becomes -2. So in other words, as x goes to infinity, f gets very close to -2, and this is already telling us that y equals -2 is a horizontal asymptote. So the horizontal line with y-intercept -2. What about -infinity? Actually, same thing. So the function is very close to the leading terms. It's very close to -2x squared over x squared, which is also -2. So yet again, we can say y equals -2 is a horizontal asymptote. Now, what about vertical asymptotes? Here you have to be a little bit careful. It is not always just the domain of the function. You need to make sure that the numerator and the denominator is simplified. And let me, for instance, give you a cautionary tale. Like, let's say, for instance, x minus 3 squared over x minus 3. You might be like, okay, the vertical asymptote is at x equals 3. But that's not true, because you can simplify this and get x minus 3. So this function would look like something aligned with the hole, but that's not a vertical asymptote. You need to make sure the function blows up. So, back to our problem. To find a vertical asymptote, let's simplify the numerator and the denominator. So for f of x, all right, so we need to factor this out, so we get minus 2 times x squared plus 2x, and then minus 3, I believe. And x squared minus 4, that's x minus 2, times x plus 2. Okay. And then the numerator, let's factor this out. So you want to write minus 3 as the product of two numbers which sum to 2. So for instance, I believe 3 and minus 1 works. So this tells you that we have x plus 3 times x minus 1 over x minus 2 times x plus 2. And notice, this is simplified. Okay. There's no other factors that we can cancel out, which is why now we can just look at the domain. So here we were kind of lucky, but in general you have to be careful. So now for the domain, notice the only way the denominator is 0 is if either x is 2 or x is minus 2. So the vertical asymptote here is x equals 2 and x equals minus 2. Because that's basically where the function blows up. All right, and then just to conclude, let's just quickly draw the graph of the horizontal asymptote and the vertical asymptotes. So again, suppose you have this thing. Then as I told you, the function blows up at x equals 2 and at x equals minus 2. And it kind of approaches y equals minus 2 at infinity. So again, that is the answer to your question. If you're curious of what the function looks like, again, I'm not 100% sure what it looks like, but it might look like something like this. I don't know, maybe like that, and it approaches this. Again, not 100% sure, but something similar to that. All right, congratulations. You have survived the third round of Extreme Algebra. And if you like this and want to see more math, please make sure to subscribe to my channel. Thank you very much.